Vertical farming is becoming more popular, and the level of vertical farming technology and innovation used to operate them is improving at a rapid rate. Vertical farming relies on controlling key aspects of the growing environment to increase grow time and crop yield. Vertical farm technology has key areas like CEA, controlled environment agriculture, lighting technology, air control and IoT integration. Let's explore each component and the vertical farming technology behind them. The foundation of vertical farming is built on the concept of a CEA, a controlled environment agriculture, using technology like AI, IoT, sensors and machine learning to create ideal growing conditions. Before we jump in, I want to give you something. If you work in the food industry or are interested in market trends and food innovation, download our free market trend reports. Take a look at some of the fastest growing segments in food industry such as vertical farms, ghost kitchens and more. Link is in the bio. Controlled Environment Agriculture, CEA. Controlled Environment Agriculture is all about creating the best conditions possible to promote growth and yield quantities. Smart sensors often connected to the IoT monitor variables such as temperature, carbon dioxide, oxygen, lighting, humidity, nutrient concentration, pH, pest control, irrigation and harvesting. Typically, controlled environments involve hydroponic, aeroponic or aquaponic grow systems. Moreover, controlled environment agriculture can utilize advanced imaging and sensor technologies including cameras and thermal imaging to measure plant growth, temperature and other factors. Presently, controlled environment systems have proven highly effective in growing leafy greens, herbs, microgreens and vegetables such as tomatoes, peppers, melons and sweet corn. Controlled environment components. Nutrient delivery. When it comes to ensuring crops have optimum nutrition to speed up growth, sensors are implemented to give farmers the ability to monitor water pH, temperature, salinity, and nutrients present in the water solution. Having an automated dosing system enables growers to have more control over the nutrient solution without having to spend much time fixing pH, EC, nutrients, and temperatures. Additionally, plants are supplied with a precise amount of nutrients, avoiding plant shock or stunted growth, which are often a consequence of imbalanced growing conditions. Sterilization systems. Because crops are in such close proximity and staked on levels about each other, it is essential to ensure the environment is sterile. One of the benefits of vertical farm systems is due to the lack of pests. They do not need to use pesticides. To ensure the production of pesticide-free crops all year round, vertical farming practices rigorous sterilization and disinfection strategies. The two most common technologies used to maintain sterile conditions is UVC sterilization. UV sterilization. Most vertical farms use UV systems which emit a high-frequency light that destroys bacteria. Fungi and viruses can destroy up to 99.9% of all microbes. It is chemical-free. Ozone sanitation. Another method that is used to sterilize the air is ozone sanitation. By using high levels of ozone gas, it can effectively kill most microorganisms present in the air. Recapturing water from moist. Vertical farms use either a hydroponic, aeroponic or aquaponic growing method. These methods use 95% less water than horizontal farms. A way they further reduce their demand on water is by recapturing and recycling irrigation water. Plants generally lose most of the water they are provided with during the process of transpiration, and some vertical farms collect this water using dehumidifiers and air conditioning. After being filtered and treated, the captured water is reused in the production process. Lighting. In indoor farming, the natural light is replaced by artificial lighting. The color intensity and duration of light all have an impact on plant growth and yield. In vertical farming, a great deal of research goes into selecting the best performing light source, since every stage of plant development has different lighting requirements. Many lighting companies provide light formulations known as grow recipes to vertical farmers, helping them maximize their yields. The three most common types of grow lights in indoor agriculture are high pressure sodium lights, HPC, and LED lights. HPS, high pressure sodium lights. The technology for HPS lights have been around since the 1950s and were originally developed for street lighting. In vertical farming, HPS grow lights are very popular since they emit mostly red and green light, which are essential to promote growth and fruiting. Additionally, HPS lights emit a lot of heat, which can stimulate growth but can also lead to a stringy formation of certain herbs and salads. LED lighting. NASA were the first to unlock the potential of LED for growing crops, and since then have become the premier choice of the next generation of vertical farms. LED lamps produce light when an electric current passes through a semiconductor. A wide range of crops is grown indoors with LED lights, including leafy greens, tomatoes, and herbs. The reason for their popularity is simple. Firstly, LED lights generate less heat than HPS grow lights, which allow growers to stack more levels of crops, maximizing yield and maximizing the output of their vertical farms. Secondly, they have a long life because they rarely fail and give a consistent light output over the course of their life. Thirdly, LED lights consume 85% less energy than traditional bulbs, thus reducing energy-related costs in vertical farming. Air control. Monitoring air levels. Carbon dioxide is a crucial element for the photosynthesis process, and even the slightest drop in optimum levels will directly affect plant growth and productivity. It has been reported that CO2 enrichment promotes rapid plant growth and increases plant productivity. There are many different kinds of CO2 enrichment techniques, ranging from traditional low-tech to high-tech sensors-based ones. Misting aqueous CO2 by CO2 delivery solutions. One of the most interesting ways CO2 can be enhanced is through misting CO2 into the grow chamber and supply CO2 directly into plant leaves. A CO2 solution is misted directly as micro droplets onto the plant's leaves via an overhead misting system. The method reduces the amount of CO2 needed to reach optimum levels needed for growth. Airflow. Airflow is an aspect that is important not to overlook. Many technologies feed into creating the perfect airflow for growth, such as vertical farm layout, proper filtering to ensure excess moisture is taken out of the air and the correct gas mix is present in the growth chambers. When plants transpire, water vapor is released and the air humidity can increase. Crops thrive mainly between 40 to 50% humidity levels and do not adapt well to fluctuations. Too high and the produce will bolt, and too low will lead to stunted growth. A very high level of humidity can lead to a fungi growth, which could result in complete crop loss if not treated immediately. Vertical farms rely on dehumidifiers and dehumidification systems to maintain their humidity levels in check. Dehumidification systems remove excess moisture from the growing environment in order to control its relative humidity and dew point. Moreover, Dutch researchers developed a dehumidification system that avoids excess evaporation into the air. By recycling their own water and natural humidity, vertical farms can conserve about 10% more water than traditional farming. The Internet of Things, IoT. IoT is making huge strides already in agriculture to boost yield, monitor crops at any given time, and make farming more efficient. IoT has huge benefits for vertical farming, to giving farmers the ability to control the growth environment, analyze crop growth, and make it more efficient. Smart sensors give real-time feedback on all growth criteria, from pH levels to nutrients in the water to light impacting the crop. Technologies have advanced so much that Agricola Moderna, an Italian vertical farm, has been able to extract critical information about the presence of macroelements in their crops, such as nitrogen and phosphorus. In plants, these macroelements are great indicators of plant health. Data collected by an in-situ sensors is transmitted in real time to a central server, where artificial intelligence and machine learning can be applied to analyze the data. This enables growers to make the most of their data, identify patterns, and troubleshoot any problems in record time. Check out our video on the 3 different types of vertical farms, which explains the difference between hydroponic, aquaponic and aeroponic vertical farm systems, or our video on the disadvantages of vertical farms. If you work in the food industry or are just interested in market trends and food innovation, download our free market trends reports. Take a look at some of the fastest growing segments in the food industry, such as vertical farms, ghost kitchens and more. Link is in the bio.